All right, let's get started. So today we are going to go over question number 4 from the midterm review worksheet. And this specifically pertains to a question about int lists. So let's just dive right into this question here. This question is asking us to fill in the blanks below to correctly implement remove duplicates, right? So before we actually start writing the code, let's just explore what this class is about, right? We know that this class is an int list. So without looking further, when you think about int list, you really have to think about the basic implementation, right? An int list is just a bare node with two items. It has, two variables, right? So it has an item and it has a reference pointer to the next node. So just the most basic vanilla implementation of a list. Okay, and that's correct, right? If we look at how it's constructed. So as a public integer item, and it has a pointer, a reference to next, which is an int list. Then we look at the constructor, which is straightforward, right? You construct a list or a list node basically by putting in an f or an integer f and a list r, which can also be null if it's the end of the list. So that's good. And now we are tasked to implement a function called remove duplicates, which takes in an int list p, and given it's sorted list of items, remove duplicates, right? So I write down sorted because it might be important, okay? And another thing that's really important to understand is that this question is asking us to make this function such that it is destructive. So when you think about destructive methods, we really have to a bell should start ringing in your head and be like, okay, we want to mutate a list. We don't want to return a new list. The int list p that we put in as an argument here, we want to make sure that we are changing the pointers and references there. All right. So enough about that. So we have enough information now to start writing the code now. Okay. So when we look at this code here, we see a while loop. So this question likely will require us to work with iteration and not with recursion, for example. And it has an edge case here, and it's asking us to implement current and previous. Let's start thinking about the edge cases. In what situation would you not be able to access any node? Well, if your list is null, then you can't do anything with that, right? So we are just going to return nothing if that's the case. So if p equals null. All right. And then we start looking at the rest of this coding question. It's kind of confusing, right? Like it's asking us a lot from us, all these blanks. But again, when you see so many blank lines, make sure to calm down. We are not asking you to reinvent the wheel here. We are asking you, or we already have some basic idea, basic skeleton for you that you will need to implement this. All right. So we're going to understand the logic that this question is requiring from us. So current and previous. We're working with two pointers here. It's also doing a while loop here, and it's comparing two items here, right? So we're removing duplicates. So you're probably comparing the current item with the previous item. So we can fill that out already. Like what else would it be comparing it with? Then it's asking for a clause where two items are the same. So there is a duplicate, or it's not the same. And then this happens outside of this. So this is probably something universal that we always need to do at the end. All right. So it's asking for current and previous, right? So I draw out some basic visualizations. I really think it's useful for an exam if you just draw out some basic cases to just visualize it a little better. That's going to be really helpful if the code is very convoluted, because you can keep track of stuff more easily. Okay, so it's asking us to implement previous and current, right? Previous and current, sorry. Previous and current. So we know that current has to be the current node that we're working on. Well, you can make current the first node, right? Because where's previous going to go? So it makes sense to make current p.next. So in that situation, it would be the second node. Correct. And previous would be the first node then. All right, we have done that, like that's out of the way. So now we want to know, when are we at the end of the list? Well, if C is the last item of the list, right, then it's going to be null. So, well, C is not equal to null, or current is not equal to null. You want to do something. As we established before, current and previous item are the same here. So this is scenario number 2, where 2 items are duplicates. In plain English, what we want is, we want to get rid of this, right? We want to get rid of this node. And how do we do that? Well, the question is asking us to modify previous.next. Previous.next. So we want to make sure that we have a list called 1 and 3. So the next item after the first item should be pointing to this item here, right? p.next. Or current.next. So we're going to change this pointer to here. All right. And what is the other situation, the else statement? Then the 2 items are not the same. So you don't really care, like, or actually you do care about this item. You want it to keep this in the list. So you don't have to do anything with this pointer here. But what you do have to do is you want to make sure that previous is pointing 1 further, because we want to prepare to compare 2 and 3 with each other, right? So that's why we are making sure that previous is equal to current. All right. All right, and now we want to check the next 2 items. Well, current is still 1 behind, and in all situations, you want to make sure that you proceed current by 1. So current equals current.next. And as you see here, you can just proceed by 1. Traverse through the list. And now you're comparing these 2 items with each other. And then a good question here is that students are like, but this node is still in the list. Well, technically is, but you're not referencing it anymore. So Java garbage collector would just come and be like, bye. So it just removes this code here. All right, so yeah, one very important tip here is that if you see these kind of questions where we already lined out like a really guiding skeleton, make sure that you understand the code. Like, don't jump straight into this question. Make sure you understand what it's asking for you. And what really helped for me is drawing out a mini example, which really helps visualizing different scenarios.